My name is Josué Robles, and my pet element project will be on selenium. Before we start with the more detailed information on selenium, here's some basic information on this element. Selenium belongs to group 16, period 4 of the periodic table. Its symbol is Se. Its atomic number is 34, and its atomic mass is approximately 80 AMUs, or atomic mass units. Selenium is a non-metal. Now let's talk about the history of selenium. This element was discovered in the year 1818. Johns Jacob Berzelius and J.G. Gahn, two Swedish chemists, were studying the chemicals involved in the production of sulfuric acid. They accidentally stumbled upon an element that they identified as tellurium, which had been discovered just 30 years earlier. However, Berzelius knew that tellurium was rare, so he took this element home to inspect it more closely. It was here that he realized that this element's properties differed from that of tellurium's. Berzelius had discovered a new element. Now, tellurium and this new element were similar, so Berzelius decided to name the element in the way that would reflect this relationship. The name tellurium stems from the Latin word tellus, meaning earth. So, Berzelius named the element selenium, which stems from a Greek word meaning moon. With modern technology, the atomic composition of selenium has been discovered. As you can see, there are 34 protons and 45 neutrons in the nucleus of its atom. There are a total of 34 electrons, 2 in the first shell, 8 in the second shell, 18 in the next shell, and 6 in the outer shell. Therefore, selenium has 6 valence electrons. There are 3 main forms of selenium called allotropes. Allotropes are the result of varying bond arrangements between atoms. They may be categorized by being amorphous, which means that they have an undefined shape, or crystalline, which means that their shape is more defined. One of these allotropes includes both amorphous forms of selenium. It can be black glass or red powder. Another allotrope is a crystalline monoclinic allotrope. It is more cubed than crystalline hexagonal selenium and has an extremely dark red tone. The last recognized allotrope of selenium is crystalline hexagonal selenium. This has sharp edges and is a metallic color. Furthermore, selenium has been known to exhibit photovoltaic behavior. This means that it can use light to help create electricity. Selenium is also photoconductive, meaning that exposure to light makes it more conductive of electricity. Moreover, selenium is non-toxic and nearly essential. Well, at least when it's not in compounds, otherwise it is toxic. Selenium is reasonably reactive. Some of the substances it combines easily with are hydrogen, fluorine, chlorine, and bromine. In addition, selenium combines with both nitric and sulfuric acids. When selenium combines with some metals, it forms selenides, such as magnesium selenide. When magnesium selenide burns in oxygen, a blue flame can be seen as it forms selenium dioxide. Selenium serves multiple functions in the world. For example, its photovoltaic and photoconductive traits make it useful in solar cells. Selenium can also convert AC electricity to DC electricity. Additionally, selenium is used in electrophotography, which allows photocopies to be made. It also decolorizes glass. But most importantly, selenium is crucial to the health of plants and animals because it helps strengthen the bones. There are even selenium tablets that one may purchase at almost any pharmaceutical store. Since its discovery in 1818, we have learned more about selenium's composition and properties. With this knowledge, we've been able to make use of selenium in ordinary lives. Nonetheless, it is important to explore other elements, as selenium is just one of the many on the periodic table.